Okay, welcome to the lecture number 54. So, we have been discussing about the gyrostate. So, we derived the equation of motion for the gyrostate in the expanded format, and now we are going to linearize that system in order to get the basically once you are trying to control the satellite and you are looking for the local control, means the small disturbances have occurred, and for that you are trying to control the satellite. So, in that case you have to linearize it and get into the linearized equation of motion. So, we have done it so many times, okay, for the gravity gradient satellite, for the spin stabilized satellite. So, for them we have linearized the equation of motion and we have written that. So, it is the same part, only thing some extra added things are added here. Okay. So, here the external torque, see once we are writing the equation that m external, and then we are writing here as m 1 and the other part as m 2 and the third part as m 3. So, this can consist of m gravity gradient plus m disturbance plus m torque due to other things, like there may be the torque due to the solar radiation, torque may be due to the aerodynamic drag, okay. Then torque may be due to the thrusters, then torque may be due to the magnetic field, okay, and so on, just keep adding. Okay. So, the torque, this is along one direction. So, this will be corresponding direction torque, we have to write it like this. So, here what I am going to do, that this part will be always present, okay. The moment due to gravity gradient, this is moment due to gravity gradient. So, it is a customary to write this equation what we have derived earlier. So, instead of just writing I will just write m 1 instead of m g 1, okay. And this this quantity will be equal to minus 3 omega 0 square, which we have written as omega n square in the gravity gradient equation. So, n equal to omega 0, this is the orbital frequency of the satellite. This is the orbital frequency of the satellite, and this times minus I 2 minus I 3, and then also we have written here C 2 C 3 3 3. Okay. So, these are the coefficients from the direction cosine matrix, and obviously, this is along the body axis. So, one body axis, and if this linearized equation has to be modified. So, simply on the right hand side, say if I expand the previous equation here written, this particular one. So, if I write here the gravitational term, the m g 1, and the other terms right now I will ignore and put that is 0 whenever required. So, you can just insert that value on the right hand side, I will get the equation. I will show you what I mean. So, as I work, so that will be much more clear. Okay. So, in that context, so we start with our equation. So, m 1 this equal to, so I will write it on the right hand side. Let us first write the, I will copy this part first from this place, this whole thing. So, j 1 times omega 1 dot, okay, here while writing everything has got into the I 1 I 2 I 3 form. So, maybe I will modify this to I 1, I 2 and I 3, okay, because otherwise everywhere I have to change. Okay, let me do that change. This is J1, J2, J3, J1, J2, so here then this becomes omega 2 times omega 3 J2 minus J3, and then pick up the other terms which is H2 dot and plus omega 2 times HW3 minus omega 3 times HW2 and minus H0. This is what is here, HW2 minus H0, and we write here M1 on the right hand side. So, this M1, instead of writing here M1, the gravity gradient term which I will pick up from this place and write here. Okay, this somehow or other here 6 is written, this should be 2, this is 2 and then this on the 3. Okay, so here we are writing the gravity gradient term which is J2 minus J3 times C23 times C33. Okay. Now, what I was telling that this is only the gravity gradient term, and other terms right now I am assuming 0, okay, like the m solar radiation plus m aerodynamic torque plus moment due to the say you have the thrusters, okay, moment due to the magnetic moment or the magnetic field. So, all these things I will assume this to be 0 right now, okay, and I will simplify this equation. So, whenever required on the right hand side of this equation, if you put these quantities, so automatically you will get the linearized dynamics along with the other terms. Now, this term here H2 dot is present, this term can be utilized for steering the satellite. Okay. Inside, if you change the angular momentum of the this wheel, okay, by actuating a motor. Okay. So, by changing this, you will produce a torque on the, as if you are speeding it up. So, the main body will also feel a torque in the opposite direction. Okay. So, along the 3 axis, by using this H1, H2, H3, we can steer the satellite, and that is the internal control. And the external control occurs like from the solar radiation, from the magnetic moment, from the aerodynamic torque and so on. Okay. So, therefore, it is shown here on the left hand side, because this is internal part and the external part can be shown on the right hand side. So, this gravity gradient which is present here, so it has appeared on the right hand side, but as we simplify this equation. So, we will take it on the left hand side itself, and right hand side will put to 0, and any time you can put the other forces there and do the computation. Okay. So, in this context, we need to look into the what will be the corresponding angular velocity in terms of theta 1, theta 2, theta 3. So, what exactly we have done? We need to 2 and the 3 page. So, your satellite is, this is the EO3 direction, EO1 cap, and the satellite is like this. So, the 2 direction is going inside, and so the orbital angular velocity, it lies here in this direction, or the orbital frequency, it is a corresponding vector, it will lie here, because it is the satellite is going here along this in the orbit, and therefore, it will lie here in this direction, which we have written as omega 0, or the same thing as n we have written, omega 0 or n, the notation we have used. So, this is your E2 positive direction. So, satellite is going in this orbit, and then it is a perturbed from this condition. Okay. So, we are measuring the angles from the orbital reference frame. So, angles are being measured, this we have discussed earlier, but here I am again repeating for the sake of your convenience. So, angles are measured from the orbital frame. Which one? The first rotation whichever you choose. Okay. Thereafter, the things will change. Say this is your right now, it is this is the corresponding axis which is shown here. So, if I give rotation about the first axis, so this rotation about the first axis, so I should show in the positive direction. Positive direction will be toward this. So, this will go from this place to this place, and this will go here. So, this is 1, this is 2. So, this will become 1 prime and this will become 2 prime, this is 3. So, 3 prime will remain here. The next rotation I give about the 2 axis. So, this rotation I am writing as theta 1, this is theta 2. So, all the rotations angles are measured from the orbital reference frame for the first rotation, and thereafter it has changed, because now it has become I 1 prime, I 2 prime, and 1 prime, 2 prime and 3 prime. So, no longer this is the orbital reference frame. So, 3 sequential rotation we can give. Say first we have given about the 3. So, we are writing that as theta 3, not theta 1. So, this is theta 3, which is equivalent to psi. Okay. So, this is theta 3. Okay. So, first rotation we give as theta 3. So, this is the corresponding rotation matrix. Thereafter, we give the next rotation as the theta 2 about the 2 axis, and then about the 1 axis, means r theta 1, r theta 2 and r theta 3. This is the corresponding set of rotation we are choosing. And inside the wheel already you are giving the bias momentum. So, you are giving the bias momentum along this direction. I told you that it is along the E2 direction of the body axis. So, right in the beginning your body axis is coinciding with this frame. So, your body axis is like this, this is E1, this is E2, and vertically down is your E3. So, H0 will be pointing right in the beginning here in this direction. If you give disturbance, so this H0 vector will be then in other direction. So, H0 is bias momentum. So, I am not giving it along the positive E2 direction, okay. But this will always point opposite to E2 direction. So, if you are from this, say in the next level, once you have disturbed it by this, so one will come to this position, and then the body axis will be here. This 2 prime position it will come your body axis 1 prime, 2 prime and 3 prime. Okay. So, your H vector then will be just opposite to this 2 prime direction. So, this is what we are calling as the bias momentum. So, this is given to the wheel, and this will help maintain the orientation of the satellite if the wheel is large or the velocity of the wheel is angular velocity of the wheel is very high, a small wheel very high angular velocity. Okay, so, we go about doing all these things. So, in your equation of motion where I 1 times omega 1 dot it is appearing. So, we need to find out this omega 1, omega 2 and omega 3. These are your inertial, or you simply say the absolute angular velocity of the body frame E 1, E 2 and E 3, means with respect to, this is with respect to the E frame. And therefore, we need to, if we are trying to work in terms of the theta 1, theta 2, how with respect to the orbital reference frame your system is getting disturbed, what will be its orientation with respect to the orbital reference frame, that we will measure in terms of theta 1, theta 2 and theta 3. Okay. So, this omega 1, omega 2, omega 3 must be converted in terms of theta 1, theta 2, theta 3, as we have done earlier also. Okay. So, let us convert that. So, first I will simply state those values and thereafter I will do that. I have done it earlier also, but again I will repeat theta 2 minus n omega 3 equal to theta 3 dot plus n times theta 1. And how we are getting? For this we are using the information that omega, this will be equal to absolute angular velocity omega r plus omega 0, means this is the orbital reference frame, and or either we can write it this way. First we write omega 0, and with respect to orbital reference frame how your body is moving. So, that gives it the absolute angular velocity. And what this quantity is? This is omega 0 times E 2 cap O with minus sign. Okay. Here your angular velocity is directed along this direction, okay, which is the negative E 2 direction. Okay. So, this will come with minus omega 0 times E 2 cap, it is pointing along this direction. And what this quantity is? This quantity is your angular velocity with respect to the orbital frame, okay. But we will take it along the body axis. Okay. With respect to the orbital frame, this is omega r 1, omega r is the angular velocity of the satellite with respect to the orbital frame, but components taken along the, later on we have to do, but components along the body axis. So, obviously, that we are trying to measure in terms of, we will write this as first as omega r 1, okay. Omega r 1, say in the matrix notation we can write as omega r 1, omega r 2 and omega r 3. So, this the left hand side in the matrix notation, this can be written as omega 1, omega 2, omega 3, this is the absolute angular velocity, this is the absolute angular velocity. Okay. So, we have to get up to this equation. Now, omega r 2, omega r 3, these are the body rates, and they are connected with, as we have derived earlier, like if you remember, we have written the equation in terms of the phi dot, theta dot and the psi dot, and this we multiplied by a matrix and converted it to the corresponding P q r, or we have used the notation for this perhaps omega r 1 or omega 1, I do not remember exactly. So, this is the notation, means this is the angular velocity along the body axis, x body axis, y body axis, z body axis, or either the 1 or the 2, and this is along the third direction. And this matrix we have written here. Okay. So, this derivation I will not be doing here, I will just recall from the previous one. So, here your omega r 1, omega r 2, omega r 3, this can be written as 1 0 minus s theta 2 0 c theta 1. I am repeating it, there was no need to repeat, but because it is not a book where I am writing here. So, it will be difficult for you to immediately go back to the lectures and look into that. So, therefore, I am just repeating it, c theta 1 times c theta 2, and this phi dot theta dot psi dot, then we are writing as theta 1 dot, theta 2 dot and theta 3 dot. This is what we have done. Okay. So, if we assume small angles, so this gets reduced to 1 will remain 1, this will remain 0, and this will be minus theta 2, this remains 0, theta cos theta 1, this becomes 1 for a small theta 1, theta 2, theta 3. So, theta 1, theta 2, theta 3 are small, so that approximation can be done. Okay, these are small. So, this one gets reduced to theta 1, and this part is 0, this is minus theta 1, and c theta 1, c theta 2, that becomes 1 times theta 1 dot, theta 2 dot, theta 3 dot. So, this gets reduced to, now we can see that we can write this as theta 1 dot minus theta 2 times theta 3 dot, theta 2 times theta 3 dot. Okay. And the other part, this we can write as theta 2 dot plus theta 1 times theta 3 dot, and this one as theta 3 dot minus theta 1 times theta 2 dot. So, this is your omega r, this quantity, then it becomes. Okay. Thereafter, if you see these are the terms which are together, these are the small terms. Okay. So, this is the second order term. So, we ignore it. So, conveniently you can remember that omega r 1, omega r 2 can be replaced by this, because these terms are second order term. So, they can be ignored. Okay. Therefore, your this part gets reduced by theta 1 dot, theta 2 dot, theta 3 dot, and this part we have to write, just use it, write it properly. So, your then the omega 1, omega 2, omega 3, this vector can be written in terms of minus omega 0 times, or we are writing in terms of n. So, this we will write as n, because n is much more convenient to write. So, minus n times E 2 cap, and then plus omega r 1, omega r 2, omega r 3, which is nothing but theta 1 dot, theta 2 dot, theta 3 dot. Here EO2, this is a vector 0 1 0, this is a unit vector along the second axis of the orbital frame. Okay. So, EO2 is vector is written like this. Okay. So, if we want to convert this into the body frame, means the what will be its components along the body frame of this vector. So, that will be can be written as along the body frame as here the attitude matrix times 0 1 0, and you know that attitude matrix it can be written in terms of C 1 1, C 1 2, C 1 3, C 2 1, C 2 2, C 3 2 times C 3 3, and then 0 1 0. Okay. So, the corresponding components then will turn out as C 1 2, C 2 2 and C 3 2. So, this factor then becomes minus C 1 2, C 2 2 and C 3 2 of the attitude matrix, and attitude matrix how you are getting from the orbital frame EO1, EO2 and EO3, you are giving 3 rotations. The first rotation you have given by r theta 3, the second by r theta 2 and the third by r theta 1. So, in the sequence you are giving this rotation. Okay. So, this R matrix, this is equivalent to R, and from this we have to choose these values. Okay. So, this times n and plus theta 1 dot, theta 2 dot and theta 3 dot. Okay. And I have also okay, so if you get time, go back and look into the lectures. I have written this C theta 2 S theta 3 E 1 cap plus C theta 1. This is the how the body frame is associated with the your orbital frame. So, C theta 1, C theta 3 plus S theta 1, S theta 2, S theta 3 times E 2 cap and plus minus S theta 1, C theta 3 plus C theta 1, theta 2 times S theta 3. So, this E 2 vector is nothing but the quantity which I have shown here, and this is written in terms of E 1, E 2 and E 3, and that how you can get. You look back into the lectures, I have done this in quite details. Okay, so, I am avoiding it here. So, this quantity is basically your, the first term is C 1 2 E 1 cap plus the second term is C 2 2 times E 2 cap, and the third one is C 3 2 times this is E 3 cap. Okay. So, this term is here, this term is here, and this term is here in this place. Okay. And once we do the approximation, so in the approximation you can see that the EO2 term it can get reduced to CO2, and this will be 1 and this will be theta 3 times E 1 cap theta 3 times E 1 cap. The second term will then appear as this will be 1, and this is all the, this becomes a third order term, this particular part, and therefore, that drops out. So, this will be simply 1 times E 2 cap. Okay. And here again this term is the second order term S 2 and S 3, S theta 2 S theta 3 or sin theta 2 sin theta 3. So, this term also drops out, we are left with this which is minus theta 1. So, this is minus theta 1 times E 3 cap. Okay. So, the corresponding term then this becomes theta 3, this becomes 1 and this becomes minus theta 1. Okay. And then obviously, we can simplify all these things. So, I will write here in this place itself this result. So, if we take this part, so this becomes theta 1 dot minus n times theta 3, theta 2 dot minus n, and theta 3 dot plus n times theta 1. So, this is what you get as omega 1, omega 2, omega 3. So, this quantity is nothing but your, I will write fresh on the next page, theta 2 dot minus n, theta 3 dot plus n times theta 1. Okay. One thing also I will remind you that for a small rotation, so the order does not matter, means the we have chosen the order here r theta 3, we have used this order, but if the angles are small, so this order is immaterial, and in that case the r we have written as simply as I matrix, or the this is identity matrix, unit matrix, not the inertia matrix. So, we can change the notation maybe, and minus theta tilde cross, where theta tilde is nothing but theta 1, theta 2, theta 3. So, instead of using that much of expansion, we could have directly written in terms of this becomes 1 1 1 0 0 0 0 and minus theta tilde cross. So, that becomes 0 0, this is the skew symmetric matrix. So, minus theta 3, theta 2, theta 1 here, minus theta 2, and this is theta 3. So, this gets reduced to 1 minus theta 3, theta 2, okay, with minus sign here, this gets plus sign here, and this is minus theta 3, okay. And then this becomes 1, this will come with positive sign, here this will come with a negative sign, and this will become with a positive sign. So, this is your R matrix, okay. And this you can directly use to convert from the orbital frame to the body frame, which we have already done here in this place. Okay. So, this part we have already done here, okay, n times theta 3 minus n times. So, basically C 1 2, C 2 2 and C 3 2 we were looking for, okay, which were nothing but the this part. Okay. This is your C 1 2, C 2 2 and C 3 2. So, this is the vector we have chosen here, theta 3 1 and minus theta 1. Okay. So, utilize it and write the equation. So, thereafter we can expand the equation. Okay. Once we have got this, the rest of the things will be straightforward, and also for the small angles similarly in the inertia term, this gravity gradient term will be getting terms like m 1 equal to 3 n square I 2 minus I 3, then C 2 3 times C 3 3 and m 2 equal to minus 3 n square I 3 minus I 1 C 1 C 3 C 3 3 times C 1 3 and m 3 we get as minus 3 n square I 1 minus I 2. So, this will be C 1 3 times C 2 3. So, this we have already done. Okay. Now, we also need these quantities. Okay. So, these quantities you can choose from the this matrix here for simplicity, because the angles are small. So, C 2 3 it refers to your the terms we can choose directly from this place C 2 3. So, C 2 3 is nothing but your theta 1. Okay. So, C 2 3 this becomes theta 1, and here of course, one term is missing, here there is 1. Once we add this, we have added with minus sign, this is got, this term has got subtracted from this term. So, we are getting this. So, 1 is here. Okay. So, this term is C 23 is theta 1. Similarly, we have C 13, C 13, C 1, the first row, third one. So, this is your C 13. Okay. So, C 13 is minus theta 2, and similarly C 23 we have already done C 33. So, C 33 is nothing but your term which is present here, C 33. So, C 33 this equal to 1, okay. And we can insert it here and rewrite our equation. So, here itself let us reduce this part. So, this part will be C 13 times C 23, you can see C 23 times C 13, this will be of second order. So, this quantity will be theta 1 minus theta 2. So, this will be equal to 0. This is second order term. So, we will neglect it. C 33 is 1, C 13 is minus theta 2. So, this becomes equal to minus theta 2, and this term C 23 times C 33, that becomes theta 1. So, this term is theta 1, this term is minus theta 2, and this term is 0. Okay. Okay, so, next we start rewriting our equation. So, we have I 1 times omega 1 dot minus omega 2 H 1 dot plus omega 2 H 3 minus omega 3 H 2 minus H 0. On the right hand side we have minus 3 n square I 2 minus I 3, and the other term this is theta 1, okay, this term. Okay, so, we pick up this and here we get as theta 1. Okay. Left hand side we have to rewrite because we have not linearized it. So, omega 1 is theta 1 dot. So, that becomes theta 1 double dot, and then minus n times theta 3. Okay. So, that becomes n is a constant. So, we will not differentiate this. This is theta 3 dot minus omega 2. Similarly, this is theta 2 dot minus n, and this becomes theta 3 dot plus n times theta 1, which is omega 3 I 2 minus I 3 times this plus H 1 dot and plus omega 2. So, omega 2 again this is theta 2 theta dot 2 n times H 3 minus omega 3, which is we have to expand it. So, omega 3 is theta 3 dot plus n times theta 1, okay, times H 2 minus H 0, this equal to minus 3 n square I 2 minus I 3 times theta 1. Already we have linearized, this is the linearized part, this is the linearized part. Okay. So, this quantity we have written here. So, break up and do the approximation. This type of work already we have done. This is I 1. Okay. So, I 1 times n times theta 3 dot. Here this part we will expand it. So, minus theta 2 dot theta 3 dot n times theta 1 minus n times theta 3 dot minus n square times theta 1 times I 2 minus I 3. So, these terms are old terms what we have discussed earlier, they are the same term, only thing this each related term they are now appearing as the extra ones, theta 2 minus n times H 3 okay. Here also we can break, okay, and if we break it. So, this will be theta dot 3 times H 2 plus theta dot 3 times H 0 minus n times theta 1 H 2, and this makes it minus n times theta 1 H 0, and this minus minus that gets a plus sign. Okay. And then this term also we bring on the left hand side, I 2 minus I 3 times theta 1, this will be equal to 0. So, here the second order terms will be dropped out. So, this term is 0, this being second order, this term is dropped out being second order. Okay. And the terms like this will be equal to 0. Why? Because H 2 is initially 0 and then you are speeding up the wheel. So, this quantity turns out to be a small. So, this we set to 0. Similarly, theta 1 times H 2 we will set it to 0, and here H 0 is large quantity. So, this quantity will stay, this will stay. Here in this one also we have to break up. So, theta 2 dot times H 3. So, I will break and write it here in this place. So, theta 2 dot theta 2 dot or H 3 times theta 2 dot and then n times H 3. Okay. So, similarly, this term, this is 0, this particular term, this term will stay. Okay. So, those you can see that this n square we are not neglecting. Okay. Why? Because this is not a variable term. Your variable terms are theta 1, theta 2, theta 3, H 1, H 2, all those things. Okay. Not the n term, okay. Neither the H 0 term. Okay. So, therefore, if we rearrange the equation, so this will be I 1 times theta 1 double dot, and then we start collecting the terms related to theta 1. So, thereafter the theta 1 dot term we will collect here. So, theta 1 dot it appears theta 1 dot term is not here. So, we have the theta 1 term is there. So, theta 1 term will collect. So, this is your n square minus n square theta dot, and this is minus sign here. So, that gets it to plus sign n square theta 1 times I 2 minus I 3. So, we will take it, this gets the plus sign, and then from this place we have then this term plus 3 n square n square times theta 1, and outside the bracket we have I 2 minus I 3, and this will turn up with a plus sign here in this place. And somewhere just we have the theta 1 term available. Here the theta 1 term is, one more term is in this place. So, this is so we will put it together n times theta 1 H 0. Okay. Then the theta 3 dot terms which are present here, that we will collect, okay. This one. So, we get the terms like, we have the minus sign if we keep it outside. So, this becomes I 1 times n times theta 3 dot, and then from this place we have theta 3 dot term. So, minus minus that makes it plus. So, plus and minus sign we take it outside. So, this will come with a minus sign I 2 minus I 3 times n times theta 3 dot, okay. And then we have theta 3 dot, and theta 3 dot is also here. So, this comes with a minus h 0, because this is plus here, h 0 times theta 3 dot, theta 3 dot. So, this way we have to rearrange the terms. So, we have taken care of the following terms. We have used this term, and n times theta 1 h 0, we have used this, this one we have used, this also we have used, okay. And this also we have used. So, we are left only with h 1 dot, this term is already 0, this part, this one we are left with, okay. This part is not included because they are 0. So, we are left with plus h 1 dot minus n times h 3, and this equal to 0. Okay, so, we need to rewrite this equation in a compact format. So, we will do it on the next page. So, the first term is I 1 times, we will have to go back and look into all these equations. This term we will take it outside the n square term from this place, and then write as this basically becomes 4 n square theta 1. So, theta 1 we can take it outside. Okay. So, 4 n square, so plus 4 n square I 2 minus I 3 times theta 1 going outside I 2 minus I 3, then n times h 0 plus n times h 0 theta 1. So, this is the second term, and then the third term we pick up from this place, theta 3 dot we can flatly take it outside, and inside we have I 1 n. Okay. So, this term we can combine together. So, that will give me I 1 minus I 2 minus I 3 times n, okay, times n, and then minus h 0, minus h 0 times theta 3 dot, and the other term we have h 1 dot minus n h 3. So, plus h 1 dot minus n h 3, this equal to 0. Okay. So, this constitutes our equation for the related to theta 1. Okay. The same way we have to write for the other one also. Okay. So, this equation is fine. Now, similarly, we pick up the other also. So, I 2 times omega 2 dot. Okay. If you follow this notation and expand and work like this, so you can derive all these things. This is the circular equation we have written earlier, h 2 dot plus omega 3 h 1 minus omega 1 h 3, this equal to minus 3 n square I 3 minus I 1 minus theta 2. So, same way insert, I will take some shortcut step and leave it to you to work out these things. So, omega 2 dot will be theta 2 double dot minus n dot. So, n dot term will become 0. So, this gets lost from this place. So, we just get here I 2 times theta 2 double dot, okay. And then of course, we have the other terms theta 3 dot plus n times theta 1, and this is theta 1 dot minus n times theta 3 plus H 2 dot plus omega 3 is theta 3 dot plus n times theta 1 times H 1 minus omega 1 is theta 1 dot minus n times theta 3 and then multiplied by S 3 plus 3 n S square, and this is theta 2. So, minus minus dot gets plus. So, we will have a minus sign here in this place, and this will be equal to 0. If you have any extra moment like the magnetic moment, so we will remove this, we will simply put here the magnetic m magnetic plus m aerodynamic and so on, and this also you need to linearize, but what function they will appear, it depends on that. Okay. So, you need to rewrite in this way. Okay. But for as far as the gyrostates are concerned, so here in this case the gravity gradient obviously they will appear, and we are these terms will act as the actuating term, okay, while you we try to do carry out the control. Okay. But currently we are going to write in this way whatever is written here. Okay. So, if we rearrange it, okay. So, I hope that you will be able to do the rearrangement. I am skipping those steps and follow the approximation. We have done this here, the variable term theta 3 times S 2 and so on, those terms will be 0. So, those kind of terms you can delete. Okay. So, if you do that, so this will get reduced to minus 3 n S square I 3 minus I 1 times theta 2 plus H 2 dot. So, this is your equation number B. So, this is related to your pitch dynamics. Okay. The first one was, this one is related to the roll dynamics, this is related to the pitch. In the same way, the third equation can also be worked out. So, the third equation is I 3 times omega 3 dot minus omega 1 times omega 2, and then we have I 1 minus I 2. Always write like this, so that it is convenient to work with S 3 dot, okay. And then okay. So, in this equation the other terms also we have to write. So, those terms were omega 1 times H 2 minus H 0 minus omega times 2 times H 1, and on the right hand side we have the gravity term. So, the gravity term we need to write, which is minus 3 n S square I 1 minus I 2, and then this is multiplied by 0. So, this is equal to 0. So, right hand side here in this case it becomes 0. Okay. So, with this simplification, so this term here it is a getting out. Okay. So, rest we need to insert the values for. So, here this will be theta 3 dot plus n times theta 1 dot. Okay. And omega 1 we are replacing by theta 1 dot minus n times theta 3, and this is theta 2 dot minus n I 1 minus I 2 plus S 3 dot plus omega 1 is theta 1 dot minus n times theta 3 times S 2 minus H 0 theta 2 dot minus n times H 1 this equal to 0. So, this is the equation we get here in this case. Okay, so, if we again expand it and rewrite this, this will get reduced to theta 3 double dot theta 3 plus n times I 1 minus I 2 or I 1 minus I 2 minus I 3 this multiplied by n minus H 0 plus H 3 dot plus n H 1, which is the last term here, this, and this will be equal to 0. Okay. So, usually once you are writing this equation, so many of the books they will write it this way, the minus sign will be taken out of this, and here it will be made as a plus sign. Okay. So, instead of using here like the minus sign, if you write in terms of I 1 minus I 3, so this gets in terms of a plus sign. So, these are the some of the common changes it is done. So, what you can do that I 2, this is I 2, okay, we have started with somewhere J 1, J 2, J 3, but we have ultimately converged to I 1, I 2, I 3. So, now I cannot change it because I forgot while writing. Okay. So, there is no way of rewriting all those things, like here we were writing in terms of J 2, J 3. So, I will mention here explicitly that J 1 is identical to I 1, J 2 is identical to I 2, and J 3 is identical to I 3. For the wheels, you can use the notation like I W 1, I W 2, I W 3. Okay. So, this is your the third equation. Okay. So, this is the way we get all the linearized equations, okay. And these linearized equations are done for the local control, okay, not for the global control. So, we will continue in the next lecture. So, we have finished the gyrostate, and something I wanted to cover, I told you that in the angular momentum term, the last term there was, perhaps I have included that in my lecture or not, I have done that or I do not remember that. So, therefore, I will include that as either as a supplementary material or either I will give as the assignment. So, that once the solution to the assignment comes, you can look into that solution. Okay. So, next time we are going to start with the control moment gyros. So, here reaction wheels for the gyro states, these reaction wheels are being used for controlling this satellite. Similarly, the control moment gyros can be used to control the satellite, and they have their own advantages. So, we are going to discuss that in the next lecture, not today, because it will take time. So, we will continue in the next lecture. Thank you very much for listening.